Welcome
to the joy of coding.
Hello, and welcome to episode 68 of The Joy of Coding. My name is Mike Conley. I thought I was being clever by opening this can of pop right as the song ended, and now I have a mess on my hands. Luckily, it is a sugar-free pop, or soda as they call it down in the United States and maybe other parts of the world. And so I didn't get it on anything critical, just my hands, and now I am like a pro drying them on my pants. Hello, welcome to episode 68. We're going to be exploring some code today. If you watched episode 65, you probably watched me kind of poke around inside what's called the service worker implementation in Firefox. I've been delaying doing part 2 of that exploration, and today we're getting back to it. So if you've been waiting a couple episodes, well, now we're back to it. So let me show you my screen. Boom. There's my screen. Let me pull up the... here we go. Today's agenda. So what do I mean by agenda? For the new folk, I say this every time, so sorry for the folk who've heard it before, but for the new folk, first of all, a reminder that no plan survives breakfast. Like this sort of pop plan, I didn't expect it to explode on my hands, but stuff happens. It's like a perfect metaphor for software. And so if things go wrong during my exploration, or if I get way off topic, it could happen. Just bear with me. I'm going to try and stick to exploring service workers. We'll see if we can do that for an hour and a half, and we'll see how it goes. First of all, I just want to check if everything's working. You can hear me. Yeah, my audio's going through, and I'm recording. Okay. Special shout out to KW01F, who apparently this is their first time watching live instead of watching it on YouTube afterwards. So welcome to the live stream, KW01F. I hope this is enjoyable for you. If you're if you missed out on part 1, I've got a link to this. Hang on. Let me talk about the agenda. So this agenda, this thing I'm looking at right now, this document full of links, you can actually get a copy of this to click on the links and follow along. If you scroll down, if you're watching this on Air Mozilla, there's an additional links section, and there should be a link to the agenda there. Let me just double check that I did that, because now I can't remember. Here is today's video, and it'll probably start talking soon. Welcome to the live. Don't talk. And then let's see if it's today's agenda. Yes, I had hooked it up properly. Okay, good. So you'll get this page, and then you can click on links and stuff. And like as I update it, because I might update it, it'll synchronize like that, and then you can just like reload this page, and you get a fresh copy of the agenda. So feel free to click on these links to follow along. It's in the additional links section. So better know a gecko. That's what this is all about. Again, this is part 2. If you missed part 1, maybe go back and check episode 65. But let's figure out what we're doing here. Better know a gecko service workers. I've got my note here. There's a link to this note in the agenda. So if you like go over here and you follow this, that will take you to my notes for better know a gecko. And where did we get to last time? Well, I had looked at like service worker registration. That's kind of what I was poking around in. And I was trying to, at the very end, I was confused about some of the structures I was seeing. In particular, service worker registration info, registration data per principal, and service worker info. And I was interested in knowing what are these things and what do they do. So let's try and find that out today. Let's see if we can get a sense of what these structures do, and then maybe explore some other parts of the service worker implementation. So service worker registration info, let's start there. What is that? I'm going to create different sections for each one as I gather data about them. Per principal and service worker info. Now I can't exactly remember, but I have a feeling, so I write here, I know the numbers relationship between service worker registration info, and I have up here, there's a one-to-n relationship between registration data per principal and service worker. So I'm going to write that down here. Here's some facts. 1-to-n relationship between registration data per principal, so 1, and service worker registration info, n. Okay, so there can be many service worker registration infos for a particular registration data per principal. Okay, I'd written that down. And that was based on looking at the registration data per principal struct. But I don't know what the responsibilities of these structures are. So what are they? What do they do? What are they for? We've got one fact here. Let's see if we can figure out more about their relationship. So we're going to use trusty old DXR or SearchFox. Either will do. Let me bump up the zoom. I don't know if you noticed this. There's like this new zoom indicator in the URL bar in Nightly. One of our outreach interns, KDB, worked on that. Dropped in this amazing patch that puts this up in here. Pretty happy about it because now I can see how I'm zoomed. So service worker registration info is referred to in a couple different places. Here's it in, I guess, a header. Maybe I'll start with the header to see what it's defined as. So this is the definition of a service worker registration info. It's a class and not a struct. I'm gonna write that down. So it's got a class, not a struct. So it's a bit more complicated than your average bear. It's got some number of controlled documents. Okay. The last update check time. And then it's got some pointers, some smart pointers to a service worker infos. So, okay, there appear to be references to several service worker infos in a service worker registration info. Now what are they? There's M evaluating worker, M active worker, M waiting worker, and what's the last one? M installing worker. Interesting. And these are service worker infos. Okay. Interesting. Okay, so then there's a scope of some kind. That's a string. Oh, we talked about scope in episode 65. I think scope has to do with like the page or something, or the the domain, or maybe the path. Something about the URI is the scope. Then the principal of the thing. A principal is like the identifier, the unique identifier for the like web property that is making us do a thing with a service worker. Then we have these listeners. Okay, we have a bunch of service worker registration info listeners. It might be interesting to look and see what this interface does because it might actually give us some clues as to what a service worker registration info is expected to do. That's just a tip. You know, if you've got a class and you're not sure like what exactly it does, take a look at the stuff that like listens to it, and maybe you can get a sense of how outside consumers of the class expected to sort of behave. So this might be worth exploring in a second. When unregister is called on a registration, it is not immediately removed since documents may be controlled. I also think I need to pull up the documentation on service worker registration. Service worker registration. So let me zoom this in. The service worker registration interface represents the service worker registration. You register a service worker to control one or more pages that share the same origin. So the lifetime of a service worker registration is beyond that of the service worker registration objects that represent them within the lifetime of their corresponding service worker clients. What? The browser maintains a persistent list of active service worker registration objects. So let's look at an example maybe. I think we had looked at this last week, but let's look at it again.
Here we go!
We check to see if there's a service worker. So this example is looking for Navigator service worker, and when it finds it, it's going to call register, pass it. There's our scope. Pass the script that we're attempting to register. So our registration is beyond that of the service worker registration objects that represent them. The browser maintains a persistent list of active service worker registration objects. Okay. Well, let's keep digging through this class. Service worker registration info. It's constructed with some kind of scope and a principal, and then we say when you can control a document. We keep a count of how many documents we're controlling. I don't know what it means to control a document, but it's something that it can do. We can clear it, try to activate it. We can activate it. We can finish activating it. Notify listeners on change. Maybe schedule update. And then we can get the service worker infos for evaluating, installing, waiting, and active. Set active. Transition waiting to active. Okay, so this seems to be pretty important, this thing, the registration info. Especially because, like, it seems to like have all of these registration infos. Sorry, service worker infos. This, like, I have a feeling the relationship goes like this. There is one registration data per principal for some, like, there's one, like, suppose I'm at mozilla.org, there is a, for the principal of that web property for mozilla.org, there's only one registration data. And then there can be any number of registration infos, and that's with anytime someone on some script on a mozilla.org site calls navigator service worker register, and then there can be any number of those, and then for each service worker registration info there are several service worker infos. So I think that's the sort of general hierarchy here. That's the impression I'm getting. Can I back that up? The hierarchy seems to be one one registration data per principal, naturally, which can have several service worker registration infos, which itself can have several service worker infos. Okay. So what's this? Let's look at that listener thing. What does this thing do? There's this. I need to look at the actual interface definition. The listener, it's just an on change. So a service worker registration info listener can receive an on change. Notify listeners on change. So if we have any listeners on the service worker registration info, we can tell them which service worker. I don't know what that is. But we can, like, oh, this might be, these are like bit masks. We're doing some bitwise stuff here. We get the service worker manager, for which there should only be a single, like that's a singleton. And we say invalidate service worker registration worker. This, the changed workers. I don't know what that means, to invalidate the registration worker. But then for each one of our listeners, we tell them on change. Okay. And what what do we have that like implements this interface? Um, does anything that we know of implement this interface? Does anyone ever call like service worker like add listener? Service worker. Hmm. Client. What does add listener look like? What's the API? It just takes a single thing. I don't know if there's anyone really that uses add listener that I can see. Oh, add listener. Service worker manager add listener. What's this? SWM is what? Service registrations. What is SWM? That's probably the global service worker manager. But is there like an on change? On change. No. Well, let's see whenever this thing was added. Maybe there's a should emit an event when its script spec property changes. This was added not that long ago. In Firefox 45. Sorry, let me bump this up. So closed out 9 months ago. And what does it do? Should emit an event whenever its script spec property changes. So you can add a listener. Is there a test? Yay, there's a test. That always helps. Get the service worker manager, and then you can add a listener to the registration change, and then register. So wait for iframe load. Example, wait for iframe load, iframe. What are all these business? Oh, that's the helpers. That's not the test. So iframe. Here's a test. Service worker. Check that the service worker manager does not notify its listeners when a service worker is registered with the same scope as an existing registration. That register should not have been notified. Then we service worker manager add listener. That's for the register listener. So all these different listeners. And then registration info. A test for the registration info. Woo! Okay, so we spawn a thing. It's getting an iframe. We wait for the iframe to load. And we load this URL. We wait for it to load. Okay, and then the change handler is not guaranteed. The is changed. So wait for a registration. We're going to send it a message to register. And then it should register. And then we're going to say return wait for service worker registration change registration. Registration change. So there's this like worker 1, worker 2, or worker.js is what we expected to change to, and then worker 2. And that sounds familiar because, yeah, here we go. We're inside. This is the iframe, the web stuff that's loaded in the iframe. And then on the register message, what we do is we register worker.js, and then when we receive another message, then we register worker2.js. So we I guess that makes it so that we can only, maybe a page can only register one service worker at a time? And when we do, we say that it's changed. What does this say? Should admit state changes. For service worker debugging, we currently don't have to wait when installing waiting active work for a given service worker changes. When it's installing waiting or active worker changes. All these different workers. Installing active waiting. That's these things. Evaluating active waiting installing. I think that's what these are. So what's a I got a feeling we got to figure out what a service worker info is. That seems, excuse me, pretty important. Service worker info is also a class. Wherever the spec treats a worker instance and a description of said worker as the same thing, for example, resolve foo with blah blah blah, we represent the description by this class. Let's spawn a service worker in the right global when required. So there's also an IDL interface, SI service worker info. And what it is, it's like information on the script spec, the cache name, and then we can get a debugger for it, and then we can say attach or detach. What is a service worker info though? It has a principal, a scope, a state. We have instances. We hold raw pointers since the service worker constructor ensure the addition or removal. There's a high chance there being at least one service worker associated with this all the time. Alright. Let's look inside the implementation of a service worker info. I'll start with the constructor. There's a bunch of other things here, but where's the constructor? Service worker info, service worker info. Better have a principal. The scope and the script spec and the cache name better not be empty. Okay. And that we don't do much. Although we create a service worker private. What's a service worker private? Service worker private is a wrapper for managing the on-demand aspects of service worker. Handles all event dispatching to the worker. Ensures the worker thread is running when needed. Oh, I haven't really been reading this, but there are 3 case rooming tokens. So it's like there's a one-to-one relationship between a service worker info. Let me write this down. There seems to be a one-to-one relationship. Whoops. One-to-one relationship between service worker info and service worker private. Like that's an internal representation. Service worker private might be an internal representation, whereas service worker info might be like what we expect the API to be like as maybe the spec changes for service workers. Maybe this is where it changes in the service worker info class, but the private maybe is more stable. Because this service worker info seems pretty thin. It's not a whole lot going on here. We can also get or create an instance. That sounds good. I wonder if that's a static. Get. It's not. It's not static. I thought maybe it would be. Oh, a get or create an instance of a service worker. Okay. And what's a service worker? So, seems to know how to create service workers. So what's the service worker class do? Create instance, and then you pass the service worker info to the service worker. I wonder if service worker info is some kind of like state. Update state. Yeah, I wonder if it's like a state class. Append a worker. So a service worker info can have several workers. M instances. M instances. Okay. There is a 1 to n relationship between service worker info and service worker. So I'm going to add another one here, service worker. There is like a single ID despite there being all these different instances of the service worker. So what does a service worker do? Like the service worker class itself. It can get events. That's what the DOM event target helper does. It handles state change and error events. You can send a message to a service worker. Let's look at the implementation. Very thin. Again, this is a very thin implementation. Service worker visible. Oh, that's... So if we are constructed, we have some info, we'll append to our info. What? So, okay, they hold on. Can a service worker have multiple infos? Info. No, there's just one. I don't know why we call it append then. Append worker. Oh. We tell it that we're... I see. We tell it that now we are also a worker for you. For the info. This is us telling the service worker info. We are a worker in your group. And this is us telling it we are no longer a worker in your group. You can post a message to a service worker. Client info. You get the private class. So the service worker private maybe is like the most interesting part here. Maybe I should reread this comment. Service worker private is a wrapper for managing the on-demand aspects of service workers. It handles all event dispatching to the worker and ensures the worker thread is running when needed. Okay. Lifetime management. To spin up the worker thread, we own a worker private object which can be canceled if no events are received for a certain amount of time. Oh, wait. Worker private. So service worker private owns a worker private? Or is it referring to us being the thing that goes away? Oh, no. It's talking about a worker private that service worker private owns. Man. The worker is kept alive by holding a keep alive token reference. Extendable events hold tokens for the duration of their handler execution wait until promise is resolved. Hold a token for idle time in seconds after each new event. All timer events must be handled on the main thread because the worker may block indefinitely the worker thread. When service worker private's token expired, if there are still wait until event, right? Stop controlling documents not handling push events. The content process is shutting down. Adding an API function for a new event requires calling spawn worker if needed. So it looks like this is service worker private is in charge of like spinning up a thread to do a thing. Drop the worker private. Terminate a worker. Spawn worker if needed. Who calls that? Service worker private, the implementation. So it's called all over the place. It looks like spawn worker if needed. So if we like send a message, um, create event, keep alive token, wait until handler, post message to service worker, and we return a promise. So sending a message to a service worker, how does that work? Service worker registration. Um, waiting active, push manager sync, update unregister. Can we send a message to it? Active, waiting, installing, and scope. Maybe I need to know more about service workers. Client, there are all these parts. Provides reference to a service worker. We register a service worker, then we have a registration. We see if we're installing. And then we've got like a service worker will exist on side the registration. Then we have like some kind of state change thing. Wow, this is a complicated API. All right, I'm gonna bail out a little bit on piecing these classes together because I think this is not gonna work. I think my better plan would be to try and understand the service worker API. I'm gonna go to the cookbook page and like try and see how they work. Maybe that'll give me a better sense of how the pieces all work together. So let's start with some general use cases. Maybe we can go over to like more advanced stuff. So I think these tell us what kind of use case we have. B means beginner, I is I guess intermediate, and A is advanced. Yeah, difficulty advanced. So immediate claim. This recipe shows how to have the service worker immediately take control of the page without waiting for a navigation event. I'm glad they give a use case. So basic service worker registration requires a navigation event to occur before the service worker starts working. This recipe illustrates a trick you can use for the service worker to immediately start working upon install. Requires a navigation event before it starts working. Okay, so let's look at the demo. A random picture by Lorem Pixel. Update service worker. Refresh to allow service worker to control this client. Nothing registered. We are already registered. I don't understand how this is supposed to work, but okay, great documentation. Cool. I'd love it if I could like collapse this a little. Okay, I'm gonna read this out a little bit. Maybe we can examine this. This function simulates a simple interface update code that reflects the current state of the UI, updating an image and a version number. So if we have a service worker controller, we get the controller script URL. Otherwise, we say we're registering. So I guess if you register, only when you register, then you have a controller, right? Service worker controller. What's a service worker controller? Service worker controller. Service worker object is available in the act property and the service worker controller property. So much redundancy. This is a service worker that activated and controlling the page. The service worker has been successfully registered and the controlled page has been reloaded. Okay. So if there's a page controller, otherwise we register. Refresh to allow service worker to control this client. And then if the controller changes, we say that it did change. We say what script URL we change to. When we click on the update button, we're going to say, when you're ready, update the registration. What does registration.update mean? Check for update. Fetch update. Fetch update happens a couple places where we'll like get the random image, then we'll fetch a version. Then we have like the server. The server is what it's going to. The service worker is updated every 10 seconds. So get service worker. And it's just going to pick some random number. Buffer. Path. Version. Month. Date. Hours. Minutes. Seconds. You join it all up. Result type. Send buffer. When we go to serviceworker.js. So when we're getting the service worker code, we send this thing, but I think we're like doing other stuff. TPL compile path. I guess we make sure that it's fresh. Then when we get a random cached JPEG, we like send a request to lorem pixel. Serviceworker.js. What are we doing here? When we are installed, oh look, we like do this interpolation thing. Is that because, how do we version install? I don't know what this means, this double curly brace, but when we're installed, we will fetch random cached, or we'll wait until we fetch random cached. When we activate, just for debugging, list all control. It's usually called after worker was installed and the page got refreshed. I don't understand what this demo is showing. Update service worker. Maybe if I go to about debugging and I like clear out the service worker. Service worker immediate claim. Unregister. I'm going to unregister all of the. Well, that's interesting. The Guardian is using it. Okay, so let's go back to this page and see what it does when I reload it. On load. So was it added? Yeah, here we go. Immediate claim. Refresh to allow service worker to control this client. Registered immediate claim on controller change. So like, are network requests going through whenever I click this button? They are not. Oh, I understand. I think I understand. I think I understand what's happening. All right, hold on a second. Let's reload the page. Get the default. All right, now whenever I update the service worker, I go out and get this image, but now it's cached. I think that's what it means. Like, we're cache, deleting old cat, deleting the no match, just list all control. On activate, fetch, demo. Let's go back here. Is there serving random? The service worker serves it. So I'm gonna get rid of the CSS. Serving random.jpg from its cache. But if I unregister this and then reload the page, checking for update, the service worker is installed. We go and get this image. I think the service worker saves the image in its cache and it checks for an update. Maybe I need to like check maybe I'll wait for 10 seconds to have elapsed. 8, 9, 10. What point does it like update the image? Maybe it never updates the image. Transferring from the service worker. It doesn't want to update, and maybe that's expected. And then whenever I reload the page, it pulls this from the service worker cache. Interesting. Okay. I still don't fully understand the use case of service workers. Maybe that's what I need to I need to read something more introductory. Service worker introduction. This was from way back in the day, December 1st. This article may be out of date, so Google looks like it's got this like primers. This might be useful. Mozilla's been working with Google and Opera and a bunch of other people trying to get this spec'd out. Actually, I think it was a couple weeks ago, 2 or 3 weeks ago, Microsoft, Google, maybe someone from Opera, I don't know, but they all showed up at the Mozilla office and they were hacking around on service worker API specs. A script that is run by your browser in the background separate from web page, opening the door to features which don't need a web page or user interaction. Push notifications and background sync. The core feature discussed in this tutorial is the ability to intercept and handle network requests, including programmatically managing a cache of responses. So the reason one result is that you can support offline experiences, giving developers complete control over what exactly that experience is. But not for multi-page sites. Service workers have been designed to avoid these common pain points. It's a JavaScript worker, so it can't access the DOM directly. Instead, a service worker can communicate with the pages it controls by responding to messages sent via the post message interface, and these pages can manipulate the DOM if needed. Service worker is a programmable network proxy, allowing you to control how network requests from your page are handled. It will be terminated when not in use and restarted when it's next needed, so you cannot rely on global state within a service worker's on-fetch and on-message handlers. That's interesting. If there is information that you need to persist and reuse across restarts, service workers... So that might have something to do with our service worker and service worker info. Like, the service worker might go down here. It will be terminated when not in use and restarted when it's next needed. So like we might spin one up, but it'll be for the same service worker info, maybe. Make extensive use of promises. Okay. The service worker life cycle. Service worker is a life cycle that is completely separate from a web page. You need to register it, which you do in your page JavaScript. Registering a service worker will cause the browser to start the service worker install step in the background. During the install step, you'll want to cache some static assets. If all the files are cached successfully, then the service worker becomes installed. Once you've cached some static assets, if any of the files fail to download and cache, then the install step will fail, and the server will not activate. The service worker won't activate. You'll try again next time. That means if it does install, you know you've got those static assets in the cache. When we're installed, the activation step will follow, and this is a great opportunity for handling any management of old caches. After the activation step, service worker will control all pages that fall under its scope, though the page that registered the service worker for the first time won't be controlled until it's loaded again. Once the service worker is in control, it will be in one of two states. That's interesting, though the page that registered the service worker for the first time won't be controlled until it's loaded again. Once the service worker is in control, it will be in one of two states. Either the service worker will be terminated to save memory, or it will handle fetch and message events which occur when a network request or message is made from your page. So no service worker, to installing, to activated, to idle, to terminated, or fetch message. One of these things. Okay. So far so good. Prerequisites. Even Safari has dropped hints of future development. Need HTTPS. That's good. Register a service worker. Register. You can call register every time a page loads without concern. The browser will figure out if the service worker is already registered or not and handle it accordingly. Aha! So if you attempt to register, do this multiple times, it's okay. You'll notice in this case the service worker file is the root of the domain. This means the service worker scope will be the entire origin. In other words, the service worker will receive fetch events for everything on this domain. If we register the service worker at example, the service worker would only see fetch events for pages whose URL starts with /example. That's interesting. So it depends on where the script is. Now you can check that service worker is enabled. That's Chrome thing. Okay. Install a service worker. So after registration, there's install. After a controlled page kicks off the registration process, let's shift to the point of view of the service worker script, which handles the install event. For most basic example, you need to find a callback for the install event, decide which files you want to cache. So we wait until we're installed. Inside of our install callback, we need to take the following steps. Open a cache, cache our files, and confirm whether all the required assets are cached or not. So for example, here are all the things to cache. We add event listener, install, wait until caches.open cache name, then we have a cache. We add all of these. You can see we call caches. So caches is some kind of like global that's available to us with a cache name, after which we call cache add all and pass in our array of files. This is a chain of promises, cache open that. The event wait until method takes a promise and uses it to know how long installation takes and whether it's exceeded. Wait until. Event.wait until. I don't actually understand how that works. Event wait until. Extends the lifetime of the event. When called in an event handler associated in the install event, it always delays treating the installing worker as installed until the past promise resolves successfully. This is primarily used to ensure that the service worker is not considered installed until all of the core caches depends on are populated. Example. We wait for a push event. We received a push. Yay, a message. You received a push message. We wait until show notification. Wait until it delays treating the installing worker. Call an event handler associated with the activate event. It delays treating the active worker as activated until the past promise resolves successfully. I see. So it's a way of delaying. If you're receiving an installing event, you can delay entering the installed state using this. It's kind of a weird API. Okay, so I think I understand that now. So in this case, we say that what we're doing here is we're preventing us from entering the installed state until all this is done. If all the files are successfully cached, then the service worker will be installed. If any of the files fail down, the install step will fail. This allows you to rely on having all the assets you'd find. Okay. Cache and return requests. After a service worker is installed and the user navigates to a different page or refreshes, the service worker will begin to receive fetch events. So we fetch, and then we can respond with something from our cache. If our caches match the request, then here we've defined our fetch event, and within event.respond with, we pass in a promise from cache.match. Finds any cache results from any of the caches your service worker created. Cache hit return response. Clone the request. If our request is a stream, it can only be consumed once. Since we're consuming this once by cache and once the browser for fetch, we need to clone the response. Fetch, so we clone the request, then we actually do the fetch. Check if we received a valid response. Add a callback to then on the fetch event. So it's like if we hit a cache hit, then we just return our cached result. Otherwise, we attempt to hit the network. And once we hit the network, we see whether or not we got a good response. And if we did, then we clone it, and then we open the cache and put the response in. Okay. You'll need to update your service worker JavaScript file. When the user navigates to your site, the browser tries to re-download the script file that defined the service worker in the background. If there is even a bytes difference in the service worker file compared to what currently has, it considers it new. Aha! At this point, the old service worker is still controlling the current page, so the new service worker will enter a waiting state. Aha! When the currently open page of your site is closed, the old service worker will be killed and the new service worker will take control. Once it does, its activate event will fire. One common task will... the way I'm understanding it is a service worker is a great way of man-in-the-middling yourself, or like creating a man-in-the-middle on the network layer from a page, a web page. And that's the point. I think it's so you can cache stuff for offline access. Cache called... I'll split this into cache for page and one cache for blog post. This means the install step would create two caches. And then the activate step, we want to delete our older cache. Moving through the caches, deleting any caches that aren't defined in the whitelist. Rough edges and gotchas. If installation fails, we're not so good at telling you about it. If a worker registers but then doesn't appear in the list, it's likely failed to install due to an error being thrown or a rejected promise. The defaults of fetch. No credentials by default. By default, requests won't contain credentials such as cookies. If you want credentials instead, call fetch and then that. No non-cores fail by default. Fetching a resource from a third-party URL will fail if it doesn't support cores. If you add no cores option in the request to overcome this, you'll tell if the response was successful or not. Interesting. Ooh, this is an interesting page. Is service worker ready? This is from Jake Archibald from Google. Using service workers today. Service worker demos. Wiki engine demo. This is a simple proof of concept wiki built using the service worker. Install the service worker to just point the browser to custom URL to begin editing the wiki. All the pages are volatile and persistent until the browser's while the browser's open, so you can open as many tabs as you want and all of them will behave the same. So like test page. Hello, this is a test. Submit query. Done. So now if I go to this in another tab, it works. If I do it in a new window, should also work. Yep. Now what about in another browser? If I open up Firefox Beta in a different profile. Actually, hang on a second. And go here. It's 404. Interesting. So I'm actually only creating it in my own browser. That's neat. That's neat. Where I can essentially like fake creating these like pages. I can like probably edit them, but it doesn't have that feature. Okay. What else? What other demos? Substantial demo. Offline news. Okay, so I'll bet if I went offline, like if I told Nightly to work offline, so this will kill all the network activity in Nightly, I can still do this stuff, whereas if I were like to try and reload this, I'm in offline mode, but like I still have all of these things that works offline. Connection is not secure though, that's okay, I guess. This works offline, and then if I go back online and then refresh this, what do I get? I don't know. That's neat. That's neat. What kind of stuff's going on? I hit the service worker, and there's like all these 200s from the service worker. Transfer, what is that? Transfer what? Sorting and sending. How much transfer? Did very little. And then if I shift reload, that's whenever I get some stuff. Whoopsie daisy. Some stuff came in when I shift reload. But if I just normal reload, I get it all from the service worker. So I flush the cache. Whenever I shift reload, I actually cause us to go get it. That's interesting. Hello, hello. Can you hear me? I'm sorry, my audio is muted. Thank you very much, Smurf D, for noticing. I think I accidentally hit the button on my mic control. I apologize for that. Thank you again, Smurf D, for noticing that. Just for you, Smurf D, I'm gonna give you an aw yeah
Oh yeah.
and an air horn. All right. So what I was saying, hopefully you didn't hear. Hopefully you heard some of what I was saying. I was looking at like this post message API and how it like takes a message channel. This is kind of interesting. This is different from how you would communicate with like a another window or something. Hello, Smurfd. And so we create a message channel, and then there's like a port 1 and a port 2, I guess, and that's how you communicate with a message channel. Maybe there are other ways of using post message, but let's just see. Client post message. And then a transferable object, such as, for example, a reference to a port. Yeah, in this case, we're using message channel port 2. That seems to be the the common pattern here. You create a message channel What is a message channel? When iframe is loaded, oh, you can actually, you can use this to, so we've added this in 41. It's available in web workers, constructing the message channel interface. So remember how I was talking about you could like post message, you could post message. It sounds like there's this new, this is API I wasn't even familiar with, which will allow you to like maybe make it easier for other people to hear the same messages. Hello, channel port 2. Because you could potentially pass a bunch of things in here. Channel. Run the example live. Hello from the main page. So page 2 on message. You could have any number of ports on the event. You could have a bunch of ports. That's interesting. Message channel interface. The channel messaging API. The channel messaging API allows two separate scripts running in different browsing contexts attached to the same document. So for example, two iframes, the main document and iframe, two documents via a shared worker or two workers to communicate directly. The two ports of the channel can be accessed through the properties. The app that created the channel uses port 1 and the app on the other end uses port 2. It's like a walkie-talkie. They are neutered on the previous context, the one they previously belonged to. For instance, a port, when it is sent, cannot be used anymore by the original context. Note that the only two objects that can be transferred are array buffer and message port. The other browsing context can list for the message using message port on message and grab the contents of the message using events to close the ports. Why would we want to do this though? Using channel messaging. Channel messaging is mainly useful in cases where you've got a social site that embeds capabilities from other sites into its main interface via iframes such as games, an address book, or an audio player with personalized music choices. When they're standalone units, things are okay, but the difficulty comes when you want interaction between the main site and the iframes of the different iframes. For example, what if you wanted to add a contact to the address book from the main site, add high scores from your game into your main profile, or add new background music choices from the audio player onto the game? Because of the security models that web uses, you have to think about whether the origins trust one another and how the messages are passed. Message channels provide a secure channel that a single data item can be sent down from one browsing context to another, after which the channel is then closed. I see. The sending context asks the receiving context for the capability to send a single message. The receiving end of the message's action is appropriate. Simple examples. So you can create an iframe when the iframe loads, create a channel, and we post a message to it. And then when we handle a message, we run iframe loaded function containing an on-click handler for our button. When the button is clicked, we prevent the form submitting as normal. That's here. Create a new message channel. Send the value entered to the iframe via the message channel. We're calling window post message. Because like the reason I'm so interested is because I'm not used to using transfer here. In a sequence is a sequence of transferable objects that are transferred with the message. The ownership of these objects is given to the destination side. They're no longer usable on the sending side. Interesting. We are posting a message to the iframe's window context. Window post message has 3 arguments, unlike message port post message, which only has 2. An object, the ownership of which is transferred. In this case, we are transferring the ownership of the message channel port 2 to the iframe, so it can be used to receive the message from the main page. And then we put an on message on a handle message on the port 1. But in the iframe, we wait for a message, then we create a list element, a list item, we append it, and then we say to port 0, message received from iframe, we say what the data is. Now what are we sending down as the data? The data, what would we, message was data, text context. What is the data? The value, post message. It's the data. And then we were on the main page. And it is received back from the iframe confirming that the original message was received successfully. Simply outputs the confirmation to a paragraph and empties the text input right for the next message to be sent. So let's look at the example. Sorry, here's the example. Send a message. Oh, look at the style. Message not yet sent. Hello? Message received by iframe. Hello? Are you there? Interesting. Two completely different browsing contexts. Like, I wonder if it's possible for the other page to be hosted completely. Like, let me try an experiment. I'm going to clone this locally. Git clone, not Mercurial. And then channel messaging, multi-message. And then I'm going to change the script, sorry, the page to point to have the iframe be the one that's over here on GitHub. So, for example, this page, this frame, view frame info, that's this one. I'm going to point it there. So it's going to be the one that's, I've got, the main page will be hosted locally, and then the, here, this is what I'm doing. Let me pump up my font a little. So I'm creating a simple local server, and then I'm going to see if this works. And then, so this outer page is being hosted on my machine, and then this inner page is the one that's on GitHub. Is this going to work? Holy smokes, it does. That's neat. So this is a way of bypassing the same origin, but I guess in a safe way. I guess this bypasses same origin. Boop, 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 boop. Okay, neat. So whenever going back to our service worker implementation, we can like post a message, we get the transferable. Removing the client info. What? So have I answered my original question? I want to know what these things do. I want to check my assumptions. So is there one of these, what a registration data per principal, just one per principal? That's what I expect that to be true. And it looks to be the case, yes, because like I know that the service worker manager is a per process global. So there's only one. And in the parent process anyways, I guess, I don't know if how this will work with E10S. But then we have the hash key, and then we have the registration data per principal. So I think that's true. There's only one of these per principal. And then inside the registration data, It's just a simple struct that has some information about the registration, but then also we have all the registration infos. Service worker registration. So we have all of these, and there's one of service worker register. So this is all the particular registrations for a particular principal, and then there's this like lightweight. This is like the sort of shell around the service worker itself. A service worker info. There could be any number of these for I guess a particular page. No, there can only be 4. It depends on what state it's in, whether it's evaluating, active, waiting, or installing. So there could be and it's going to be in like I don't know if there's ever one in all of them, but I think there's only 4 at max, and at minimum I would guess 1. But if I had to guess based on state, I would say that this is only set if we're evaluating, this is only set if we're active, only set if we're waiting, only set if we're installing, and all the others might be null pointer. And then a service worker info is like a lightweight service worker, and as soon as you like do a thing or like say that the service worker needs to be alive, then we actually spawn the thread of execution, which is the service worker itself. But when it goes away, we keep having this info around, but this is like a very lightweight shell around a thing that is short-lived. And I think that's the relationship. I think we figured out the relationship. Whew. And I've actually learned a lot about service workers by like dicking around, screwing around, poking around in all of these demos. Interesting. So like what do I want to look at next? I mean, there's a lot to look at for service workers. Like I could try and see how it works over E10S. That might be the next thing. So how does a service worker, how does the service worker API work with E10S? That's the next question. And you know what? I think there's not enough time to really properly answer that. I'm going to give a little teaser. We got like 10 minutes left. I'm going to give like a little teaser, and we're going to look inside the IPDL, which is the Inter-Process Communications Protocol. We're going to look at that and see what kind of messages it sends. So it looks like I can never remember like who's implementing. Receive, register. The parent. So the child can send a register message and unregister. So the child probably has its own service worker manager, and then it tells the parent whenever things register, unregister, or shuts something down, and then the parent can then tell the child whenever things get registered, unregistered, and when things get removed, and when to just like straight up delete the service worker manager. So like send, notify, remove all. That's if like we remove all service workers for a particular parent, maybe a principal or something. We get the service worker registrar and we say remove all. What's the parent ID used for? Parent ID. We look through the agents. We get the key, the parent of the agents. We get the key. And if we get the parent with the ID that is not parent ID, propagate, remove all. So everything but this? Interesting. We say, what's the parent ID? Then we send the message to remove all. What is this? MID, service worker manager parent. Why do we need an ID? We use this ID in the service in order to avoid the sending of messages to ourselves. Oh, I see. I see. If that's our ID. And if we're not that person, then remove all. Okay. Okay, so starting to piece together how it works with E10S, but I think I'm going to leave that for now. And I think I'm going to cap this episode 9 minutes early because my neck is really hurting. I don't know why. I think it's because I worked from home yesterday and I sat in a kind of a nice armchair, but not a great hacking chair. And I need to stretch. So I'm going to cap the episode here. Thank you so much for watching episode 68 of The Joy of Coding. I hope this exploration was interesting. I hope this sort of mucking about and learning about service workers is interesting for you. Let me know. There's the, if you look at the agenda, there is a rate this episode link here, and that will take you to a Google form. You can let me know what you think. And I would love to hear your thoughts. Let me know if you like this Better Know Gecko stuff, or if you want to get me to get back to bug fixing. You just let me know. So again, thank you so much for watching episode 68. I will see you next week. Oh, no, I need to let you know. I don't think I'll be airing next week. Probably won't be airing next week because my family and I were probably going to a festival together, and I'm taking the day off. So that's what's probably happening. In that case, if that occurs, then you won't see me next week. You'll see me the week after, and it's one of the two of those. You'll either see me next week or you won't, but no matter what, you should see me the week after that. Okay, so take care. Thanks for watching episode 68. I hope you have yourselves a great week, and happy hacking. Bye.
The joy of coding.
See ya.